Hello friends, and welcome to the basic course of engineering circuit analysis. So till now we have gone through a lot of theory, and in fact in the previous video we have just seen the basics of dependent sources. Now we will be doing certain numericals so that we can have a good understanding on all the theory that we have covered till now. But before starting, I would like to emphasize a few points on the importance of doing numericals in a subject like engineering circuit analysis. Firstly, practicing numericals are very important to reinforce the theory that you have learned in this course. Now, you are going to learn a lot of theory in engineering circuit analysis, but unless you are going to do numericals, it will be very difficult to reinforce the theory inside your mind. So practicing numericals is very important, and the study of engineering circuit analysis without numericals is incomplete. The numericals that you do is also very important in completing this course. Also, we will be doing a lot of numericals in this course, but however, you should practice numerical from any other source that you can get your hands on, because the more numericals that you would practice, the more good idea you would have about the subject. So now let us start with the first numerical here. It's a very simple numerical. So you have a circuit here. Now, till now we have not gone to the definition of circuit, networks, etc. But for this numerical, it is not necessary to understand that. So they have given that the V2 voltage is 5 volt, some voltage V2 is 5 volt, and they expect you to find the value of VL. So VL is the voltage across this resistor, and you can see here you are having a voltage controlled voltage source. Okay, you are having a voltage controlled voltage source. How do I tell that? Because you can see that this voltage source, okay, this is a dependent voltage source, it is having a magnitude of 5 V2, and V2 is the voltage across this particular resistor here. Okay, and they have asked you to find the value of VL. Now, if you closely note, the resistor and the dependent source here basically are connected through the same points. The point here is same as this point. The point here is same as this point because it's the same conductor, right? So basically the idea is that the value of VL will be equal to 5V2, which is the value of the magnitude of the VCVS here. Okay, so it is easy. So V2 is given to be 3 volts. V2 is given to be 3 volts. So therefore VL will be equal to 5 into 3, which is equal to 15 volts. Generally in numericals, it's better that you start with a very simple numerical so that you get a concept of what you are doing. Okay, so here the idea is that because these two elements, that is this VCVS and the resistor, are connected in the same points, the top and the bottom, this voltage here will be same as this particular voltage. There is no difference. Okay, so now let us do the next numerical. So this numerical is going to use a lot of concepts that we have studied till now. The idea is that you have to find the power absorbed by each element. So there are 1, 2, 3, 4 and 5 elements here. So you have to find the power which is absorbed by each element. That word is important. You have to find the power absorbed by each element. So let's start initially by marking the elements. Let me call this element as element 1. This is my element 2. And this is my element 3, this is my element 4, and this is my element 5. Okay, so we'll do it systematically. In generally, whenever you do solve problems, it is better to do it systematically so that you don't make any mistake. So let us start by taking the element number 1. So I'll write down that here. So element number 1. So I'll draw that separately. So this is the element number 1. This is an independent current source. So this is the element number 1, 7 ampere. This is 7 amperes. Now, you know that power is equal to voltage into current. Power is voltage into current. So, this current value you have to find out first. So, you can see that, like in the previous problem, this current source and this resistor are connected in the same point. You can see that this point and this point are same, and this point and this point are same. Therefore, the voltage across the element, that is this 8 volts, will be same as the voltage across this element, which is the 7 ampere independent source. Okay, so this voltage will be same as the voltage is going to appear here. So I can write that here. So this also will be plus minus 8 volts. Okay, now let us note the current direction. Now you can see the current is coming out of the positive terminal, right? So whenever current is entering the positive terminal, power absorbed is positive, right? I will write that here. So when current enters the positive terminal, this is just a recap. Current enters positive terminal, power absorbed is positive, and when current leaves the positive terminal, the power absorbed will be negative, or the power generated will be positive. But here in this case you have to find only the power absorbed. So you can clearly see the current 7 amperes, if I just extend it, 7 amperes is leaving the positive terminal, right? So power absorbed will be negative. You have to put a negative sign and just take the voltage and multiply it with the current. So the voltage is 8 volts, the current is 7 amperes. So this is minus 56 watts. That means this independent current source is absorbing minus 56 watts. That means it's actually generating plus 56 watts. But here they have asked only about power absorbed. So you have to calculate the power absorbed here. So now let's take the element number 2. So this is element number 2. So element number 2. So element number 2 is a simple resistor. So I'll take that here. Okay, so this is plus or minus 8 volts. The value of resistor is not given because that is not required at this point of time. Now you have to find the power absorbed, right? So power absorbed, you know that will be voltage into current. You know the voltage, so you have to find what is the current through this resistor. Now we have not gone through certain laws which will allow you to understand this concept. But by just using a little bit of common sense, you can see that 7 amperes is entering this point here. 7 amperes is entering this point, and you see out of that point 5 amperes is going through this element here, which is having 12 volts. So 5 amperes is going here. So the rest 2 amperes, naturally it has to go through this element here, right? It's basic common sense. Now this actually follows Kirchhoff's current law. That is another concept, and we will be going in depth in understanding that topic. But here you can clearly see that 7 amperes is entering this point and 5 amperes is going through here. Naturally 2 amperes will go through this particular element here. So that 2 amperes I will put here. So this is 2 amperes. This is 2 amperes. So you can clearly see the current is entering the positive terminal. So the power absorbed will be positive. So you have to take the voltage and multiply it by the current. So the voltage is 8 volts. The current is 2 amperes. So the power absorbed by element number 2 will be plus 16 watts. Power absorbed by this element is plus 16 watts. Now let's take element number 3. Element number 3. So element number 3 is this particular resistor here. So I'll just draw that separately. So it is given that this has a polarity minus plus 12 volts, and they have also given another value like this. So this is plus minus Vx. Okay, and you can see the current is entering like this. Okay, so the current is entering like this. So here also you don't have to bother about this minus Vx here because you are having the voltage and current. So power absorbed you can find directly. So power absorbed. Okay, so in this case we can see, so the current is actually entering the negative terminal, or I can tell that if I follow the path of the current, current is coming out of the positive terminal, just following the path of the current. So power absorbed will be negative. So minus sign I will put. So what is the voltage value? It is 12 volts multiplied with the current value is 5. So it is minus 60 watts. Okay, so although it is represented as a resistor, okay, usually resistor only absorbs power, but this element might be something else. It might be doing some other function. That is why you have got a minus 60 watts. Anyway, that point is not important for now. They have just asked you to find the power absorbed by each element. And the element number 3, whatever it is absorbing minus 60 watts of power. That is the important thing. Now let us take the element number 4. Element number 4. So element number 4, you can see it is this particular element here. So let me just draw that separately. Okay, so this is given to have a voltage plus minus 20 volt like this, and they have given the current which is going is 8 amperes. Okay, so if you follow the current direction, you see that the current is coming like this and it is flowing like this here. Okay, or sometimes they might give this like in the bottom portion to confuse you, but you just trace the path of the current. So here the power is entering the positive terminal. The power absorbed will be positive. The power absorbed is positive. So positive, what is the voltage? 20 volt multiplied the current is 8 amperes. It is plus 160 watts. Okay, so this element is absorbing plus 160 watts. And finally, here you are having a dependent source. Okay, so this is going to be a little bit more interesting. So let me just copy this circuit and we will take it to the next page so that you understand the concept in a better fashion. So let us find the power absorbed by the element number 5 here. So I will draw that element number 5. So element number 5. So this is actually a dependent current source. You can see that it's a dependent current source, and clearly you can see it is a voltage controlled dependent current source. So voltage controlled current source. So it is 0.25 Vx. Okay, so you can see Vx is here. That is why I'm telling it's a voltage control, and by the symbol I can understand it's a current source. So the voltage across, you can see it is plus 20 volts across the element, 20 volts, and the magnitude of this current is given to be 0.25 Vx. So you know the voltage, but the current also you know, but you know that there is a quantity Vx. Okay, so you have to find the value of Vx. So you can see Vx you can find from this particular circuit here. So I'll just draw that quickly. So it is given, this is minus plus 12 volts, this is minus plus, this is minus Vx. Clearly from this diagram you can see minus Vx is nothing but 12 volts because it's exactly the same, right? You can see the polarity is minus minus, sorry, this plus here, plus plus. So minus Vx will be equal to 12 volts. So your Vx value will be equal to minus 12. Vx value is minus 12 volts. So let's find the power absorbed. So you can clearly see, as per the direction of this current source, the current is entering positive terminal. The current is entering the positive terminal. Therefore, power absorbed will be positive. Power absorbed is positive. So take the voltage value, which is 20 volt. And what is the current value? It is 0.25 Vx. So 0.25 into Vx. So this is plus 20 into 0.25 into minus 12. Minus 12. So if you calculate this P absorbed, you will be getting it as minus 60 watts. So this particular element here, it is absorbing a power of minus 60 watts. Okay. So I hope you have understood today's numericals. And in the next video, we will be starting on certain basic laws of engineering circuit analysis.